Okay, so here is a standard question you get asked in a physics class. You shoot a bullet and you drop a bullet from the same height at the same time, and we want to know which one lands first. Okay, so that's what we're going to look at. We're going to explore that. So take a guess, and we'll see what the answer is in a little bit. So this is introducing a topic that we're going to cover now called projectile motion. So projectile motion is when an object is moving through the air in both the x and y directions. Okay, so for example, this guy kicks a soccer ball, and the soccer ball follows this trajectory like this as it flies through the air. So it's a projectile. It's kind of like flying through the air. It's moving in the x and y directions. But you might notice once the soccer ball leaves the guy's foot, there's no other force acting on that soccer ball except gravity. What do we know about when things are only being pulled by gravity, when gravity is the only force acting on an object? What do we know about that? That is free fall. Okay, so what is projectile motion? It is free fall in 2 dimensions. So when I say it's in 2 dimensions, the object is moving in 2 dimensions, but it is in free fall. Remember what we said about free fall in the past. The only acceleration is due to gravity. The only acceleration of the object is due to gravity. The acceleration, and here we're writing it as a vector. The acceleration, which is a vector, has a magnitude of 9.8 meters per second squared. The direction is downwards. Or I can write it as a component, negative 9.8 j hat. Or I can say the y component of the acceleration is negative 9.8 meters per second squared. The x component of acceleration is 0. So, just like we said before for free fall, let's go back, not projectile motion, but let's just back up. When you throw something upwards in the air, the instant it leaves your hand, when it's traveling upwards, it's in free fall. Even though it's moving up, it's in free fall. Why? Because even though it's moving up, the only force on it is due to gravity. So it is accelerating downwards at this rate, even when it's on its way up. When it's at the top of its trajectory, it's in free fall. It's accelerating downwards at this rate. When it's on its way down, it's in free fall. It's accelerating downwards at this rate. All of that is still true even if the object is also moving in the x direction. So here's an object. The moment that it leaves the soccer player's foot, the ball is in free fall. It's accelerating straight down at this rate. But it also has a horizontal velocity. So it's going to keep moving in that horizontal direction, and that velocity is not going to change because a sub x is 0. So the horizontal velocity stays the same. The vertical velocity, the y velocity, is going to change. When it's going up, the vertical velocity gets smaller and smaller and smaller. When it's going down, that vertical velocity is going to get faster and faster and faster. The horizontal velocity does not change. Why? Because it's in free fall. This projectile motion, this object is in free fall. That's what I want you to remember. This object is in free fall. On the way up, on the way down, it's in free fall. Even though it's also moving in the x direction, it is in free fall. Okay, have I said that enough times? I hope so.